Okay, let's look right now at arithmetic sequences and series, and first the difference between them. A sequence is just simply a list of numbers that has a common difference if it's arithmetic. So in this case we have a common difference of +2 every time. A series is that sequence, but they're added up to a certain number. So this one is adding all of those, so it's adding the first 4 terms. It happens to be a sequence where you're just getting the total. So 2 plus 4 plus 6 plus 8 comes to 20. You don't do that if you're just simply listing them. So these words are very important to recognize the difference. Now, a skill to have is to find the means between numbers. Mean means simply the average, but not just one single average. If you just looked for the average between these, you'd be saying -10. -10 is right smack in the middle of these two. You add them up and divide by 2 and you get -10. We're saying 3 arithmetic means. Here's what that means. You want to be saying, you put -18, there are 3 numbers in between before you get to 2. Not just one. This would be -10 if it was exactly, if we were talking one arithmetic mean, it would be -10. So, what we need to do is figure out how to get that, how to get all 3 of the numbers here. So we're going to start, well, if you think about it, how to do it would be easy if we knew one particular piece of information. That particular piece of information is the common difference. If we knew what to add to this, and then add again, and then add again, we would know all of these. So we need to find the difference. That's where this little formula comes in very, very handy. This formula is AN equals A1 plus N minus 1 times D. So AN is the amount at a certain term number. So like 1, 2, 3, 4, that's the 5th one. This 5th term, A to the 5th, the amount of the 5th term would be 2. Then the number of the 5th term would be the number 5. That's 5. So this would be a 2 and a 5. They match together, almost as if it's an X value of 5 and a 2 for the amount. Now A1 is the amount of the first number. There you are. And the difference is whatever we add. Well, here's the thing is, we now know 3 things. If we decide to use this, the 5th and the 2, and I'll write it like this, the 5 and the 2, then we can put it in. So we know the first term is this. We don't know the 2nd term or the 3rd term or the 4th term, but we do know the 5th term. So we can say that the 5th term's amount is 2. The first, -2. I meant to say, did I say negative? Yes, this is supposed to be a -2 because that's what it shows here. So -2 equals the first term plus the number of terms minus 1 times the D. Everything in here is filled in except for one variable. And the most basic foundational premise in algebra is that you can solve for any number of variables if you have that same number of equations. We have one variable and we have one equation because everything else is filled in. So let's simplify this, basically solve for D. We want to figure out what D is. So of course I have to do what's in the parentheses first for D, and then it'll be adding the 18. And so we get 4D is equal to 16. Divide by 4 and we get D is equal to 4. So now we know what that common difference is. Now we can go back up here, and I'll do it over on here. I'll say that -18, oh, you know what, I'll do it down here where there's more space. So we have -18. I'm going to add 4 to that. So that's going to become a -14. I'm going to add 4 to that, so that's going to be a -10. I'm going to add 4 to that. That's going to be a -6. And if I add 4 to that, I get the -2 that I'm supposed to have for the 5th term. So that proves that this works. So that means my answers, it says find the 3 arithmetic means, -14, -10, and -6. Okay. Now, that's a sequence where we had to find the missing numbers in it by using that formula and then using the D. Now we're going to look at finding the sum of a series. So there are two formulas that can be used. One of them is this, and one of them is this. I like to simplify this one by putting the 2 underneath. This one's the number of terms, and then the first and last term added together divided by 2, or the number of terms divided by 2 in the first and last one. To me, this is an easier one to remember as well as use. You have to have the number of terms, the amount of the first term, the amount of the last term. You do not need the common difference. In this one, you do need the common difference, but you don't need the amount of the last term. Both of them are good, acceptable ways to do it, but you really do it based upon what it is that you don't have and what it is that you do have. Then you can choose the easier one to use. Sometimes you can use one and find out some of the information a different way. We'll do that at some point too. Now, for this, what we're doing is looking at this equation. We're going to find the sum using one of these, in particular using the second one, of the arithmetic sequence 12, 19, 76, and then this is saying we want the 25th term. We want to go out and find that 25th term or use it. We want to find what's the sum if you add up all 25. Here's your first term, A1, and A2, then A3, and so on. So for this one, we need the difference, we need the number of terms, we need the first term. We don't know the amount of that last term, and that's why this is not such a good one to use. Okay, so what we're going to do here is we're going to figure out the difference based on this. 12 goes to 19. Well, do 19 take away 12. Okay, 19 take away 12 is a 7. 26 take away 19 is a 7. So it looks to me like D is equal to 7. Then we know the first term, which is of course the first term. And we need to know the number of terms, which it tells us right here. The n is 25. Plug them in. The sum at the 25th term is equal to the 25 over the 2. 2 times the first term, the 12, plus the 25 minus the 1 times the D. Well, we don't know that. Oh, wait a minute. The D we do know. That's good. A 7 is something I can overwrite D on. Okay. So we know all of these. That will give us what the sum is. So I'm going to do all the inside stuff here first. 25 over 2. That's 24 plus 24 times 7. Okay. So the sum of 25, or the sum of the 25 terms, that first 25 terms. So 24 times 7 is 168. And when I add 24 to that, when I add 24, I get 192. 88, yep, 192. Now here I can divide 2 into it, and I can then just multiply it, or I can just do on the calculator 25 over 2 times that, or 25 times that divided by 2. What it tells me is that the 25th term when I do this comes to 2,400. Okay. So here's the thing. That's the first method. It's easier to do in some ways because we have all that information. I'm going to show you, though, that you can do it with the other ones. You just have to do it as another step. I personally prefer doing it this, so I'm going to show you anyway because I think you might like it. We're going to use Sn. Some people might. Some people might want to do this. N over 2. And then A1 plus A2. That's A2. Okay. So the thing is, we know N and we know A1, but we don't know A2. So what we're going to do here, it's easy enough to figure out the 7. So what we're going to do is we're going to use the basic formula of these. I'll put it in the parentheses, and we're going to solve for the d. So an equals 12 plus 25 minus 1d. An equals 12 plus 24d. An equals 12 plus, oops, this is supposed to be a 7. I did it again. For some reason I keep wanting to do the 7s there. So that's 168 plus 12, which is 180. Now that we know that, we're going to use it with this formula. The sum at the 25th term, because we know it's supposed to be the 25 of them, is going to, oops, don't need the parentheses yet, is equal to 25 over 2. And the first term, 12, plus the 180. Sum 25 is equal to 25 over 2, 192. Oh, it's right where we were before. So we get the exact same result, 2,400. So either way, you could use them, except if you do the second one, or this one, you just have to find the amount of that term by using the common difference.